On these two problems, they're a little bit more challenging than the previous ones. At least number 9 is a little bit more challenging. The reason I say that is that I've got two expressions with y's in them and one with x in them. So I'm going to need to figure out what x is and what y is. And the x here is the only one, and there's nothing I can do until I figure out what this angle measure is. So I'm going to need this angle before I can find x, so I cannot figure out what x is first. That'll have to be saved for later. So the first thing I need to do is I need to figure out what y is. So I'm looking at this picture here and I see these congruent markings on the sides of this triangle, which means that it's isosceles, which means that we can apply the base angles theorem that says opposite the congruent sides is a set of congruent angles. So each of these angles is congruent to the other. So there's two congruent angles right here. So they're equal to each other. So here is one expression and here is the other, and we just set them equal to each other. So I'm going to set them equal and figure out what y is. So I will need to solve here. So I'm going to solve by subtracting 6y from both sides. I always move the fewer amount. That was the smaller amount. 10 minus 6 is 4y's. Copy that. Then I'm going to get the y's alone by adding 41 to both sides. So negative 5 and 41 is going to be 36. 36 equals 4y. Divide both sides by 4, and you'll see that y is 9. So I know what y is now, but I need to use y to find x. So I need to go back up into these problems, and I need to choose an expression to plug into. It really doesn't matter which one you plug into. I'm going to plug into this one because you're subtracting a smaller amount. So plugging in 6 times 9 minus 5, I'm going to figure out what this angle is. So 6 times 9 is 54, minus 5 makes this angle 49 degrees. That makes this angle 49 degrees. And 49 and 49 is 98. So if you add those together, you get 98. So we need to do 180 minus 98. So subtracting there, that's going to be 82, which means that here where we put our question mark, that angle is 82 degrees. So now that we know this angle, we can use that to find x. So we're going to set 82 equal to 12x plus 22. Just solving here, subtract 22 to get our x alone will give me 60 equals 12x, and dividing by 12 on both sides gives me 5 equals x. So that's my x and my y in that problem. It was harder than the last because we had to use the y, plug it in to find this angle, to find this angle, to find x. On number 11, it looks kind of scary because you're seeing all these expressions all over the place. I want you to notice that they all have x's in them. I want you to notice that all of the angles are marked with one arc. That means that all of the angles are congruent, and this was that corollary to the base angles theorem, which was saying if all of your angles are the same, then all of your sides are the same. If your triangle is equiangular, then it's equilateral is what that said. So I know that all three of these things are equal to each other. So that means that I have choices, and you probably didn't feel like you had choices just glancing at this problem. You have a choice of setting any two of these equal to find x. So I'm looking at this and I'm trying to think of what the easiest two to set equal would be. I'm kind of liking this one because it's got 2x, and I'm liking this one because it's 7, whereas this one is 12, and that's kind of a higher number. So I want to stay with the small x values. So I'm going to set the two that I underlined equal to each other. So again, I'm going to need to get my x's to one side. I'm going to move the less amount, which is the 2x. So it was positive, so we subtract 2x from both sides. 7 minus 2 is 5x. Still has that plus 2 on the end. That just carries down. So we're going to subtract 2 on both sides to get the 5x alone. That gives us 5x equals 15. Divide both sides by 5, and you see that x is 3. So that's x for that problem. And it wouldn't matter which two you set equal, should still end up with 3. no matter which two expressions you're setting equal to each other.